We're going to cover a number of topics. First of all, we're going to look at the software build quality trends as we measure them by SIG. Is it improving? Is it decreasing? We're going to look at the impact of software monitoring. And of course, in this period, we can't avoid to talk about Corona. Is there any impact of Corona on development quality, on the things we are seeing on production? So first look at our database. These were the numbers that we had when we did this for the first time. 4,000 systems analyzed, 215 different technologies, 25 billion lines of code. Today we're at 36 billion lines of code that we can take all this data from. So what we have is a great data set that we can look into and learn a lot from. So we've added a lot in the last couple of months, and we'll continue to do so. As you see, 170 million lines of code coming in every week. So let's first define what we're looking at. There's two main different approaches to software assurance. One is looking from the outside to, let's call this external quality. This is the defects in use. It looks at the functional suitability. Is the software correct? Is it to be accepted by the users? But we are looking today mostly at the internal quality. So we look at the quality of the software construction, because this drives cost of ownership. This drives the external quality. Let's dive a little bit deeper into that before we go to some of the findings. We've built a build quality benchmark ranging from 1 star, which is maybe on the not so good side of software, towards 5 stars, which is the best, and 3 stars being the industry average. And some of the numbers show that 60% of all the bugs that you will find are directly to be attributed to this build quality. It also shows that when you have a 2-star system and you compare it to a 4-star system, that 4-star system will be twice as fast to develop. So your cost of ownership will be twice as low, and your speed of development will be 3.5 to 4 times faster. So there is actually a lot of value in your build quality. So with that, I'd like to give the word to Magiel, who will give you some insights on where build quality is moving.
Yeah, so great to be here again, presenting data that we have collected at SIG for about 10 years, actually 11 years this year. What you see on screen is one of the graphs, one of the many graphs we'll show you in this short time period. Let me briefly tell you what you can expect. So on the vertical, on the y-axis, you see the build quality, as Luc was just introducing, ranging from 1 to 5 stars. And we've set that out in time here. So on the horizontal axis, you see the years as they pass by, and the little line, the orange line, is the overall average that SIG has been measuring every quarter. And this average is based on all the 5,000 systems so we've seen over the years. And what we observe here at the very end, and you see there when we reported last to you in 2019, you see we saw a very slight increase in that average, and actually that is continuing into 2020. So we can say the overall average that we see in quality is still going up very slightly. For SIG, that's also a reason that we recalibrate our measurement instruments yearly. We are required to do that by the TÜV, who have certified our measurement methodology, to basically counteract this trend a little bit. Today in this presentation, we'll be using the latest model in operation today, which is the 2019 version of our measurement model, to be able to see the trends over time. So there will be a lot more to come, and we'll get started by looking into industries and the technology stacks we see within our data.
Yeah, exactly. So the next thing we'll look into is actually quite fun. So we've seen that quality is slightly improving, but we also like to compare between industry sectors. We like to also maybe look at things how different technology stacks perform. So let's first look at something quite interesting. So we have taken 12 industries where we have enough data to compare. We've ordered them alphabetically from banking to telecommunications here on this list. You might see your industry, it might be that your industry isn't represented here. Doesn't mean that we don't have the data, but we didn't feel comfortable enough, we don't have enough data for that industry to be in there. So let's look at how they stack up. First of all, the difference between the best and the worst performing is quite significant. It is more than half a point in build quality, and it has a quite significant effect. And we'll go through this, and there will be a poll in a second asking you to say who's the best one, but we'll take some of the tension away to go from 6 to 12, where we see insurance performing on the 6th place, where we see media performing below average at the 7th place, then healthcare, followed by retail, followed by support services, and now it becomes, there's a little drum roll here for the bottom 2, is software and computer services. That's an ouch moment for the software industry, I guess. And there's telecommunications with a lot of older systems that are being revamped. Now there's 5 left, and we'd like to start a poll now to ask you who's performing best of the remaining 5. Who do you think ends up on top? We know, but we're interested about what your assessment is. Waiting for the results to come in. So still some final voters. And our notary is collecting the result. Is there a clear winner, according to you? But we'll look at the data. Fiercely being written down now. Give us a second and then we'll have the results. But your thoughts? Yes, Corona proof here. So 41% thinks it's banking and 21% thinks it's financial services. That's interesting. Let's look at that rating. Who's on number 5? Clearly above market average. Again, market average is 3. That's government at a respectable 5th place. Closely followed by banking at the 4th place, so not in 1st place. But so then who's 3, 2 and 1? Financial services, including fintech, is on 3rd place. Industrial transport, including ports and those kind of industries, on 2nd place, which leaves energy, oil and gas at a very respectable 1st place. So congrats to everybody who contributed to that. But importantly, of course, this is an average. There's outliers in both directions in all the industries. But now let's have a look at some of the details and some very important groups. Let's look specifically into banking and government to see if we can find some deep dive, some additional analysis there. Magiel, take it away.
Yeah, so in the overall ranking, they are about 1/10 of a point from each other, so that's pretty slim. You might ask the question how to sort of cut up the data and get more insight into this overall average. Again, here you see one of those graphs where we have build quality on the vertical axis, but now something else on the x-axis, where we split out the data set by the size of the software that we measure we call that volume. We measure it in person months, basically the amount of code that a person can build in a month. And you'll see here 2 lines. One is government, the bottom one in this picture, the purple one, that is under the banking average, basically across all the volumes that we've measured in this time period. So it's not that the banking has just, is outperforming government only on very small systems, but also on the other side, on sort of the legacy side, where the big software banking transaction systems are still in operation. Also in that region, banking has done a better job at build quality. You could also ask the question, has it been like this always, or is this something recent? Well, it seems to be mostly the latter. So when we look here again at time, so we go back to 2009, and at that time actually banking was under government in build quality. And that has only recently, in about 2018, shifted to the opposite way. So there has been a period from about 2016 that banking started making large investments in modernizing their portfolios and also changing the way they develop new software that has led to an increase in software quality in their sector. So this is saying it can be done, but it requires the investments and also other measures to make it happen. One of the things that is also interesting to explore in this data set, and that we'll use to close off this part of our presentation, is that looking at technology stacks, if you please indeed change the slide. So in our data set, we categorize software in various stacks, JVM being the Java-based mainstream software languages. There's legacy software, there's low-code software like Power Apps and OutSystems and Mendix-like platforms. Microsoft.NET is a very obvious one. Also package solutions where there's lots of custom built software against packages. And of course scripting and mobile applications. So we have a similar ranking. Unfortunately, we don't have the time to poll you for your opinion now, but we'll quickly go through this list from number 4, where Microsoft is just below the average of 3.0. Then under that is the package solutions, which are often non-ideal parts of software because they're built against the platform. And finally, of course, this is probably not a surprise to anybody, is that legacy systems sit at, getting close to 2 stars overall. But at number 3, we see JVM, Java-based applications. Number 2 is scripting and mobile. Typically, these are pretty small pieces of software, making them easier to maintain. And at number 1 is low-code and BPM. Which is recently has started to boom a little bit. So we see more and more of those systems, and they tend to be of above average quality. When we go to the next slide, we'll actually cut that out a little bit as well. So we here again see the volume of systems against their build quality. We've plotted a separate average here for low-code and BPM versus JVM and Microsoft. And there you can observe a very interesting thing is that there's a deflection point right about at about 40 person months worth of code in a system where low code starts to go under the more mainstream technologies. So there is sort of a hunch in many developers that low code is good for smaller systems. In the average, that appears to be true with respect to build quality. So for bigger systems, you might opt for JVM or Microsoft languages. Of course, we have to say these are averages, right? So there can be outliers in either direction. It's also possible to build bigger systems of high quality in low-code platforms. But, you know, it doesn't go automatically. Okay.
So that's an interesting deep dive into industries, into tech stacks. So if you want to know more, you of course can contact us and we can dive into your specific situation. The next topic is dear to our hearts because this is actually looking at the impact of what we're doing. Is monitoring software actively, does it have a positive impact on build quality, and what's the impact on the spending that you have? So Magiel will share with you some insights that we've gained over the last couple of months when diving deeper into our data. But first he will explain to you the concept of overspend, the concept of the cost of ownership.
Yeah, so when we look at a system, we have found in our experience as consultants in this domain that main cost drivers are how much of the software is there, what's the volume of this system, and the second is how is its quality, right? So what's the build quality, and those two factors have a big impact on the overall spend that you have for maintaining this code, so keeping it up and running. In this example, we have a System X. It's a hypothetical example of a 3-star, so average quality system that spends about 141,000 euros per month on maintenance. So it's quite a big system. What we'll be looking at now is a system, a similar actually the same system but at a higher quality level, so 4 stars, which is what we recommend as the build quality to be, so the benchmark build quality, then you'll see that that same system can be maintained at a lower cost due to its higher quality. And the difference between those two numbers, so the 141,000 and the 100,000, that difference is what we call the overspend. This is preventable cost that you can make sure, if you monitor properly, will not creep into your systems, basically. So when we monitor, and then we can go to the next graph that we have, SIG is measuring the code base on a very regular basis through the development of a system. So in this graph, we've tracked several hundred systems over time for 2 years. So 24 months, which is what you see on the horizontal axis. And on the vertical axis, we have the amount of overspend that such a project has accumulated over time, right? Because their quality was lower than it should be. We've started with a group here, that's the line you see, what we call the unmonitored systems. Those are systems we are measuring, but they are not aware of it. They are open source projects that SIG keeps in their database to also meet demands of our certification body, the TÜV. And so we keep track of their systems over time, but we don't provide the consulting services that go with these monitoring projects normally. When we see, it's good to observe here, is that this line is not straight. This means the rate at which they keep adding overspend to their systems is also increasing, so it probably will not stay where it is at 100% now. If we then plot in the consistently monitored systems, so these are systems that SIG has been providing consistent, at least monthly monitoring service for, then you see that this overspend basically doesn't accumulate, at least not in the average. Of course, there are always some outliers, both up and down. So down meaning any overspend that existed was actually removed during the monitoring project. Well, there's also a little bit of an in-between here. You can monitor a little bit less than a month as a frequency. Then you see some benefits compared to the unmonitored group, but also there's overspend that keeps getting added over time. Well, what can that lead to if you have a big portfolio of systems? Something we call legacy mountain, which is of course a term that has been thrown about quite a few times. We thought, let's visualize that and take our entire data set. So what you see here is a visualization of all our 5,000 systems that we measured over time, and we've summed up the overspend that some of these systems have accumulated over time. And basically that's the vertical that you see here. So a 3D plot like this is nice to get a good feeling for this enormous overspend that can be. So the yellow peaks, let's say, of the legacy mountain are at 2 million euros overspent per month for several systems that exist of that size and of that poor quality level. So we can show you this mountain from various sides if you want, so you get some feeling for where it starts and how quickly you run up in the slope of this mountain. It's possible to do this for every portfolio of systems and get a feeling for where such overspend might be in your own portfolio.
Okay, so that was very interesting information showing that it really makes sense to continuously look at your build quality to prevent costs from going down and to keep your speed of innovation going up. We only have 5 minutes left, so I want to spend good time on also looking at the impact of the Corona lockdown. Without going into too much detail, it was very interesting to go through this analysis and try to find, is there any impact? Do we see impact of the Corona situation? We do a quick poll here where we're going to ask you, do you expect that on average there was less production and more quality? Was there more production and more quality? So that was the optimal situation. Was there more production but less quality? Was there less production or less quality? Or was it just business as usual? Nothing really matters. Let's be very quick on that poll. Let's try to see what will reveal the answer after the results, because it's quite an elaborate answer. So with that said, I will continue, hand over to Magiel again to go into some interesting plots.
Yes, so these plots, they won't give away the answer, so you can keep on giving your opinion. So what we started out, and I have to say this is a bit research in progress, as obviously Corona is not over yet, and the way we adapted our working is also not back to completely normal. What we see here is a group of systems, about 400, that we've tracked for a year, and we've plotted basically their pre-lockdown performance. So you see the build quality churn as basically the change compared to the previous period, and their volume, so their production. You see here quite a scattered and diverse picture that is pretty hard to read. If we go to the next one, we'll add actually the lockdown period results. Also quite scattered, quite a lot of variation among the data. You could, you know, if you look at this hard, you could say it's shifted a little bit to the right and maybe a little bit to up, suggesting there's more production and more quality. Obviously we needed to do a better job at this, so we've modeled the behavior of every system over time using a statistical model, and then projected that out into the Corona period. So here you see the results of that. If you see the months here, December, January, February, basically the final months before the lockdown. Then we see March, which pops out because the green bar here represents systems that actually performed better than what their statistical model was suggesting it would. So they added more quality than we thought they would do in March. And this is about 15%, where about 5% is a normal variation you can expect in a month. So that pops out. You could say, in that month at least, more quality was being added than we thought. In the month April and May, however, everything is squarely in between the statistical bounds and back to normal. If we then look to the volume production, we see a pretty similar picture. It's not as pronounced. More systems were adding quality volume than we thought. Maybe the red is also a bit smaller here, but everything after that seems to go back to normal pretty quick. So I think we had a little bit of debate about what is the right answer here.
Well, what seems to be the case is that when everybody went into lockdown, working from home, production boosted, quality boosted, and after that we went back to normal. That does lead to the question, what happened there? We want to urge managers and especially development to think about that. What are the positive things you want to get back from that situation? Clearly something good happened there. As Magiel indicated, this is a research in motion. We'll report about that in the next couple of months with the situation progressing. Given time, I do want to share with you that this little booklet will be coming out soon. I actually have it with me. It will look like this, and that will contain the results of this analysis we showed you in a little bit more detail and some additional graphs. So that's the work coming to you in the next couple of days or weeks. Be looking forward to that coming into your mailbox. With that, I'd like to conclude. Thank you for your attention. There's a few things I want to share with you, wrapping up this 2020 edition, reminding you of the order of the industries. Try to get up next year by improving the build quality of your software. Look at your own legacy mountain. Where is your overspend and how can you prevent from doing it? Think about your frequency of monitoring. Think about how you can improve your build quality, showing that it really matters to do this high frequently. And especially also think about what were the good things that you can learn from that situation back in March, which clearly had some positive effects. Finally, before I hand over to our next speaker, a few things that were projects that we're engaged in. I want to take one out of it because our next speaker is actually engaged also, one of the founders of the IK project. my good old friend Carlo van der Weijer, who will be presenting the next topic on how to apply very modern technology, artificial intelligence, into your development. Everything you've seen before is about legacy code, but also includes AI code. We had a situation very recently where we analyzed a system with a lot of very fancy AI, where the question was, can we apply this across our company and other elements? Functionally, the system was top-notch, but when we looked into the architecture, it was so entangled that it was difficult to apply it in different angles. So software engineering also applies in this area.